Dilations. So consider how vertical dilations impact the graph of f of x equals x. So suppose the output values of f of x change by a factor of 4 to create a of x. So sketch the graph and complete the table of values. So if the output values, that's talking about our y values, change by a factor of 4, that means they get multiplied by 4. So if I take negative 2 times 4, I now get an output value in a of x of negative 8. So if I multiply all of these f of x output values by 4, I will get the new output values for a of x at negative 8, negative 4, 0, 4, and positive 8. So this is now going to give us a new graph. So I'll have a point at negative 2, negative 8, negative 1, negative 4, 0, 0, 1, 4, 2, 8. So this is now a of x. So identify the slope and y-intercept of a of x. So let's look at our table here. So my change in y, right, if I think about it, my change in y is that I am adding 4. And then my change in x is that I'm adding 1. So my slope ends up being 4. And then the y-intercept is in the table at 0, 0. So all of this means that if I want to write a of x, we would use a of x equals mx plus b, where m is 4 and b is 0. So technically I don't need that plus 0, but I'll just leave it in there for right now. So we get a of x equals 4x plus 0. Okay. So now suppose the output values are changed by a factor of negative 4 to create c of x. Sketch the graph and complete the table of values. So my x's, right, those aren't changing at all because we are only impacting our output values. Okay, so I'm going to multiply all of my output values by negative 4. So I get 8, 4, 0, negative 4, negative 8. Okay, so let's graph this now. So negative 2, negative 2, 8, negative 1, 4, 0, 0, 1, negative 4, 2, negative 8. So let's find our slope and y-intercept. So change in y's would be subtracting 4 over my change in x's, which is still adding 1. So my slope is negative 4. I once again have the y-intercept as part of my table. That is at 0, 0. So that means b is 0. So not a. So c of x equals negative 4x plus 0. So vertical dilations do one of several things. If the a value, the absolute value of the a value, so whether it's positive or negative, is greater than 1, it's vertically stretched by a factor of a. If a is somewhere between 0 and 1, it's compressed. And then if the a is negative, it's vertically stretched or compressed and reflected across the x-axis. Okay. So this is our last page here. So when a function is both translated and stretched vertically, you can write the function in the form a times f of x plus d, where d represents the vertical translation and a represents the vertical dilation. So describe the transformations performed on f of x to produce g of x, then write the function in general form. Okay. So let's go ahead and look here. Now, if I notice that all of these graphs for f of x are the exact same. So maybe let's figure out, well, what is the general equation for f of x? Okay. So f of x has a point here, a point here. So that means I go up 1, right 1. So that means I have a slope of 1. And then here, I notice I have a y-intercept at 0, 0. So f of x equals 1x plus 0, or f of x just equals x. Okay. So the other way we could do it is I could actually identify several points in f of x. We'll do this. So, like, I have a point here at negative 2, negative 2. I have a point here at negative 1, negative 1, 0, 0, 1, 1, and then 2, 2. And then I could transform that into x, g of x. So that's one way you could do it. Now I would say that, like, while this is helpful and this is visual because you can kind of figure out what are you doing with your x and y values, it does take a little bit more time. So I will show you both ways in this first example, but then I will probably just not really do the tables. So let's talk about what our transformations are before we create our new table for g of x. So first things first is I have this 2 here. So that means that a is 2. So this is a vertical stretch because it's bigger than 0 or bigger than 1. Okay. I would also notice here that that 7 represents D. So that means I move up 7. So what this means for g of x is that I know that whenever I talk about a vertical dilation or a vertical translation, the x values end up always staying the same. There's no change in those x values. What's going to happen though is that your output values change. So when I talk about g of x, what's going to happen is that these original y values are now going to have two things happen. We are going to multiply by 2, and then we're going to add 7. So if I take 2 times negative 2 plus 7, I get negative 4 plus 7, which is 3. So I now have a new point at negative 2, 3. So we keep repeating this process. I'm now going to have 2 times negative 1 plus 7, because I take the next y value. So I get negative 2 plus 7, which is 5. So I now have the next ordered pair at negative 1, 5. So we do the next one, 2 times 0 plus 7, which gives me 7. So I now have the point at 0, 7. So then I move to the next point. So I have 2 times 1, which is 2, plus 7, which gives me 9. So I have a point at 1, 9. And then you see the pattern. I go 3, 5, 7, 9. So we could probably infer that then we'd have a point at 2, 11. And this is now our line here. Variable line. Let's try that again. Okay. So this is now g of x. So when it comes to now writing our general form for g of x, well, that is going to be 2 times f of x plus 7. Now we know that f of x is equivalent to 1x and I know that 2 times 1x is 2x, so I have 2x plus 7 as my general form. Okay, so the table can be helpful, but the table is a lot of work. So let's forego the table on these next few problems and just talk about the transformations in the general form. Okay. So here we go. So this 1/2 is my a value because it's being multiplied. So this is a vertical compression. It's a vertical compression because 1/2 is between 0 and 1. I then have this negative 3, which is the vertical translation value of d. So this means that we move down 3. So now let's write our equation. So once again, I know that f of x is equal to x because we found that earlier. So if I want g of x, I will have 1/2 times f of x minus 3. So g of x equals 1/2 times, well, f of x is equivalent to x minus 3. So g of x equals 1/2 x minus 3 is my final answer. So let's go ahead and break this down. So what if I didn't have the ordered pairs that I had like I did from the tables? Well, we're given the general form. This negative 3 is our intercept at 0, negative 3. Okay. This 1/2 is our slope. So this is telling me I'm going to go up 1, right 2. Up 1, right 2. Or down 1, left 2. But this ends up being our line right here. Dilax. Okay. Last but not least, okay. So this A value is negative 2/3. So that actually is going to tell us two things. One is that we have a reflection, and then it's also a vertical compression. And now D here is 5. So that means we go up 5. Okay. So originally, let's talk ordered pairs. I would have an ordered pair at x comma y, or x comma f of x. What's going to happen though is because of my translations or my transformations, my x is going to stay the same, but now I'm going to take negative 2/3 times f of x plus 5. So whatever the y value is, I multiply it by negative 2/3 and then I add a 5 to it. So that is what you would find if you were to do it algebraically. So if I were to take a point, like say I took this point here, this point is at negative 1, 2, 3, negative 3. So let's say I took the point negative 3, negative 3. Well, if I wanted to convert it, the x is going to stay the same, but in the next coordinate, I would take negative 2/3 times negative 3 plus 5. So what's going to happen is this is now going to give me a new point at negative 3, comma. Okay, well, negative 2/3 times negative 3, if I plug that in my calculator, is going to give me 2 plus 5. So if I take that one step further, I should now have a new point at negative 3, 7. Okay, so you can always go back to the algebraic way if you would like. Now, if you're just going to rewrite the equation and then graph the line using the y-intercept and the slope, here's how you would do it. Okay, so g of x equals negative 2/3 times f of x plus 5. Well, I know f of x, as we said, is equal to just x. So g of x equals negative 2/3 x plus 5, where I have a b value of 5, so I have an intercept at 0, 5. And then I have a slope of negative 2/3. So I can go down to right 3, or I could go up to left 3, but this ends up being my general line right here. Okay? All right. So that is it for our translations and dilations, and then our transformations just in general.